All right, for the calculator part, remember for all of our tests and quizzes and the AP exam, you have to round to the nearest thousandth. But the only time you don't do that is when you're writing the original model. So the following data show the fuel efficiency in miles per gallon for all U.S. automobiles in the indicated year. T equals 0 is 1940. So I meant for this to be like, so you're putting in 0 here, then 10, 20. So 30, 40, 50, 60. On the quiz tomorrow, I already have these inputs here, so it's not confusing. So my labeling's a bit strange after that. Okay. Use the graphing calculator to find the quadratic regression. So let's get everything set up first. So if we want to be able to see the quadratic regression, we want to make sure it's turned on. Now, if you're in stats or other classes that messes with this, you might need to check your stat plot, second y equals. Make sure the first plot says L1 and L2. Otherwise, we're going to go to stat edit, clear out the old data. So clear, enter, and start typing in the years in L1. Those are the inputs. Again, we're typing in years after 1940 in this case. We're not typing the actual dates. And then we want to type in the average miles per gallon into L2. And I'm never going to give you a huge list of data, so do a quick check to see if there are any typos. It's easy to have typos in these problems if you type the numbers in too fast, so I'm just doing a quick check here. That all looks okay to me. Okay, to get the quadratic regression, we do stat, calc, choose option 5, quadratic regression, L1 and L2. Remember to store the regression equation so that you have the unrounded equation stored into your y1, and then calculate. So again, I want to write down all of these decimals. So this is going to be, and let's see, are we using y and x? Yes, we're using y here. We're not using x though, we're using t. So let's make sure that we have that. So y equals 0.005011948. I'm not going to write x squared, I'm going to write t squared. You want to match the variables in the model, in the table given. Minus 0.169,642,8571 times t plus c. So I'm going to bring c down here. 14.81612345. So 1, 2, 3, 4, 5. You could probably also put a repeating on that. That would be okay. Okay, so this is our model. And then part B says use the model, so use that equation, not the original table, to estimate the worst year for average gas mileage. So that just means lowest mileage, right? And lowest means that we've got some sort of parabola that opens up, so we're looking for the vertex. All right, now I don't want to use a vertex formula because I don't want to type in all of these decimals. To see this graph, if you're doing regression, instead of zoom fit, choose zoom stat, so zoom 9, and you should see your scatter plot along with the model that fits in there. Okay, so we want to find the vertex, so that's second trace. This time the vertex is a minimum, so choose minimum. And remember, you need to move your cursor. So this says left bound. So I need to move my cursor so that it's to the left of where the vertex is. So right there is fine. And press enter. And then you need to move the cursor to the right of the vertex. Enter. And it asks if you wanted to guess. So yes. So it's calculating something for us. So I'm going to write this down. This is where I can round to 3 places. 16.924. 0.924. And the average gas mileage, I don't need the y coordinate there. So the y coordinate was 13.381. I'm going to write it down. So this is the gas mileage. The question was find the year. So this is the year. So it would be about 16.924 years after 1940. Now, if you want to put a year in that, add 16.9 years. So that'd be like in 1950 1959, I would just say during. It's like at the very end of 1959. Okay, but if you just tell me this, if you label it years after 1940, that's fine. During which year or years was the average gas mileage 13.7? So we're setting our equation equal to 13.7. So now you wrote the whole equation up here. So it's okay if you just do ... for each of these. So write the first 3 decimals and then ... You don't need to round anything there. ... Okay, so I'm not going to do quadratic formula because I would need to subtract 13.7, and then with all of these decimals, I would need to type all of that into quadratic formula. It's better to just graph and find the intersection. So go to y equals, type in 13.7, and then press graph again. So see how we have these 2 intersection points? These are my 2 solutions. Every time you solve an equation, you're just solving a system of equations by finding their intersection points. So go to second trace, intersect. I want to find the one on the left first, so I need to move my cursor over here. The cursor will find whatever point it's closest to. So enter, enter, enter. So one answer is 8.948. So T is about equal to 8.948. And again, if I want to put a year in that, that's 1948, during 1948. And then the other T value, I have to go second, trace, intersect. To do that again, move your cursor so that it's closer to the other intersection point. And then enter, enter, enter. And this one says 24.900. So 24.900. And again, that would be 24 years after 1940. So that'd be like 1962, during 1962. Okay. All right. Next one. You have 50 yards of fencing to enclose a rectangular region. Find the dimensions that maximize the enclosed area, and then what is the maximum area. So draw a little picture if that helps you. I like to call my horizontal dimension x, vertical one y. So to begin with, we have a perimeter of fencing. So we have, so we have 50. 50 equals 2x plus 2y. And then we're trying to maximize an area. Area of that rectangle will be x times y. Okay, so what do we do with these 2 equations? This is just a system of equations. Solve this for y. So you can subtract 2x, divide everything by 2. When you divide everything by 2, divide every term by 2. 25 minus x equals y. And then sub that in to your area equation, because we can't type an equation with 2 variables into our calculator. So x is going to equal x times 25 minus x. And then it's a good idea to write down the domain because you want to be able to see this graph. So think about this here. X definitely needs to be greater than 0. You can't have a side length of 0. And then look at this. Y is equal to 25 minus x. So x definitely needs to stay under 25 because if it's 25, then y will be 0 and you won't have a rectangle. And if it's anything higher than that, you're going to start getting negative values. So you don't have to write this as part of your answer, but I like doing the domain because then that's going to help me see my viewing window. All right, so here's the area. I need the dimension, so I need to find x and y. So I can graph this. So clear, clear, turn off your stat plot. I'm not bothering to distribute the x through, although I could. I'm just going to do this. And then my window goes from 0 to 25. And I zoom fit. So there's a nice looking parabola, and then I just need to find the vertex. This time the vertex is a maximum. So let's go left, and let's go right, and we press enter, and it comes out to 12.5, and I'm going to write down the whole vertex. So the vertex is x equal, let me write this down, sorry. So the vertex is 12.5 and 156.25. The vertex represents an x coordinate and an area, not a y coordinate. Because remember that we only have 50 feet of fencing, so y can't be this answer. All right, so what are the dimensions? When x is 12.5, and what is my what is my label on that? Let's see. There we go. When x is 12.5, we're talking about yards. Yards. What's y? Well, remember back here, y is equal to 25 minus 12.5. So y is also equal to 12.5 yards. So those are the dimensions. What's the maximum area? Right there. The maximum area is 156.25. It's an area, so make sure you make it square yards. Now, you could also, on this one, if you can't get your graphing calculator to work for whatever reason, you could also say a is equal to 25x minus x squared, and you could also vertex formula. You could say opposite of b over 2a. That's going to give you 12.5. Plug that back in to see what the max area is. Okay, so you have options. What about number 7? You have 600 feet of fencing to go around the perimeter of this rectangular area. So 600 feet of fencing, which is a perimeter. The fencing will also split the rectangular area in half. Let x be the vertical side. Oh, okay. And let y be the horizontal side. All right, write an equation for the amount of fencing that will be used. So part A is just the fencing equation. So we have 3x plus 4y is equal to 600 feet of fencing. That's it. Write the area function in terms of x. So before you write the area in terms of x, you need to write the area, we need a length times width, right? The width is x, the length of the bottom is 2y. So the area is equal to 2y times x, or I'm just going to write 2xy. Now, we need this value for area in terms of x. So here's where these two equations work together. We need to work on the perimeter equation and solve it for y. 4y equals 600 minus 3x. Divide by 4. Now, you can either divide each term by 4, or you could just say 600 minus 3x all over 4. Doesn't matter. And that's going in for the y right here. So the area formula is going to be 2 times x times 600 minus 3x all over 4. And yeah, you can simplify this if you want to. You can say 2 over 4 reduces, but I wouldn't simplify too much because we're going to use our calculator for this. Okay, so that's the area function. What's the domain of the area function? So again, think about what needs to happen here. X definitely needs to be greater than 0 because you can't have a negative side length. And y needs to be greater than 0 too, but just take a look at this. That means like 600 minus 3x over 4, that also needs to stay greater than 0. Like this can't be calculating out to 0. So that's just when 600 minus 3x is greater than 0. And if I solve this, divide by negative 3, so flip that. 600 divided by 3 is 200. So as long as x is between 0 and 200, then I should be able to get all of the areas that generate here. All right, so you always do that. X needs to be greater than 0 and y needs to be greater than 0. Instead of y, I'm using my expression that I solved for y. Use the area function to determine the dimensions that will produce a maximum area. So find the vertex. Now, you could algebraically find the vertex, or it's probably faster, and you want to get comfortable with this anyway. It's probably faster just to use the calculator. So 2x times, now be careful how you type this in. You can use the alpha y equals to get a fraction in here. Oops. Try that again. Maybe I'll do it in parentheses. So alpha y equals to type in a fraction. The nice thing about this is that you don't have as many parentheses to worry about. Okay, or here's the other option. Put parentheses around 600 minus 3x, because I know not all the calculators have the fraction ability, and then divide that by 4. These two things mean the same thing. Just hold the numerator together, divide the whole thing by 4. All right, so anyway, I want to set my window. We said x should be between 0 and 200, and then we should zoom fit. And again, we see a nice little parabola here, so let's find the vertex. We are finding a maximum we're going left, going right. I didn't even look to see if it started on the vertex. Maybe it did. Round this to three places, so 100 and then 15,000. So the vertex is 100, 15,000. Okay, 100 represents an x, 15,000 represents an area. So use the area function to determine the dimensions. So x equals 100. What's y going to be then? So remember, y is equal to 600 minus 3 times x all over 4. So 600 minus 300 is 300. Divided by 4, I think that's 75, right? Divided by 2 is 150. Half of 150 is 75. You can use your calculator to confirm that if you don't trust it. So the dimensions are 100 feet by 75 feet. So those are the dimensions. And then what is the maximum area? The maximum area is 15,000. And again, include labels on all answers. That would be square feet because it's an area. What x values of the rectangular region will give an area of 5,000 square feet? So let's set our area equation equal to 5,000. So that equals 2x times this. And again, you don't want to waste time solving algebraically if you're allowed to use a calculator here. We already have the equation typed into y1. So we're going to put 5,000 into y2. And we're just going to graph again. It's already fit to the window. And here are the two intersection points. So second trace, intersect, enter, enter, enter. Found the first one at 18.350. So x is about equal to 18.350. That's feet. And what's the other answer? So second, trace, intersect. You've got to get your cursor back to the other side over the vertex. Otherwise, it'll keep just finding this intersection point that it's closest to. That should be good enough. So enter, enter, enter. 181 point, this rounds up 650. So you have to round to 3 places and you have to round correctly. So those are the two values for x that will give us an area of 5,000 square feet. All right, number 8. Among all pairs of numbers whose difference is 16, so x minus y equals 16, find a pair whose product is as small as possible. What is the minimum product? Okay, so this is just like perimeter and area. I've just changed the context. So this is kind of like perimeter. And then our product equation is equal to x times y. And we want to use some substitution here. So I'm going to solve this equation for, just solve it for x. X is equal to 16 plus y. So now sub that into your product equation. So product is equal to, instead of x times y, it's 16 plus y times y. And again, you're trying to find a minimum product. So I can say 16 plus, you're going to type in x even though it says y because we can't distinguish here. And then what do I zoom this to? Well, we have all possible numbers here. I could go like 0 to 16 or something, or I'm just going to zoom 6 and see what happens. I'm just going to get back to standard, zoom 6. Okay, definitely not enough, right? But I can also zoom out. Okay, that's getting a little better. And I could zoom out again, or I could just adjust the window a bit. The window, the Y minimum, let's bring it down to like negative, 60 and press graph. That's pretty close. Negative 80. There we go. I just want to be able to see the vertex so I can find it. I'm finding a minimum this time. And my cursor started on the right, so I've got to get it over to the left, press enter, move it to the right, press enter. So round this to negative 8, negative 64. So the vertex was negative 8, negative 64. Remember, this represents a y coordinate. I just solved for y. And this represents a product. That's x times y. So if y is negative 8, what is x? X is 16 plus y. So x is 8. And the minimum product is negative 64. So there are no labels here. We don't have dimensions here. It's just numbers. Okay. Two positive whole numbers have the following sum. The sum of the first and twice the second, x plus 2y, is 32. Find the two numbers that have the largest product. So again, product is x times y. Let's solve this equation for x because that's just one step to do that as opposed to two steps in fractions for y. So 32 minus 2y. Instead of x times y, it's 32 minus 2y times y. And again, I can type this in. So 32 minus 2x times x. Let's just hit graph and see if that's anywhere close. Oh, that's actually not bad. So I'm just going to bump the window up. I want the y maximum to be higher. Let's bring it to 80 and see what it does. Oh, not high enough. Let's bring it to 100, maybe 120. Okay. I think it will still find the vertex if it's off the screen, but I'm just going to bump this up anyway just to be safe. I could also be zooming out. I just know that it'll get skinnier if I keep doing that. All right, so find the vertex. It's a maximum. Enter. Get to the right. Enter. This rounds to 8, 128. So the vertex is 8, 128. The first coordinate represented a y value, and the second was the product of x times y. So when y is 8, x is 32 minus 2 times 8. 32 minus 16 is 16. So those are the two numbers. And the product is 128. Now, I'm doing this all on my calculator. Remember, you can also use vertex formula. You could do negative b over 2a and then f of negative b over 2a to find the vertex on on any of these really, but I don't want to do it on ones where I have all these fractions and decimals. Okay, now this last section, this is on the no calc part, because otherwise if I'm able to solve, I would just keep graphing and finding intersection points. But otherwise it says solve each quadratic using the most efficient method. So that means if you can factor it, you should factor it. If you can square root method, you should do that. If you can quadratic formula, do that. So this one, I think this is going to factor. 4 times 3 is 12, so I can probably get 13 out of this. 4x and x. If I put the 3 here and the 1 here, I get 12x and 1x. And what needs to happen to make it negative 13? Make them both minus. All right, so x equals 1/4 and positive 3. For this one, I'm not going to be able to do factors of 17, which are 1 and 17, that add or subtract to get negative 2. So I have to quadratic formula this one. 2 plus or minus square root of 2 squared is 4, minus 4 times 1 times negative 17, all over 2 times 1. 2 plus or minus, so negative 4 times negative 17 is going to be positive, and it's positive 68. So I have square root of 4 plus 68, which is 72. Simplify that. 72 is 36 times 2, so plus or minus 6 radical 2. And if you can divide all three of these outside numbers by something, then you do. So if you divide everything by 2, you get x equals 1 plus or minus 3 radical 2. And for the last one, I don't want to square this out and then get it equal to 0. I would rather get rid of the squared by square rooting both sides. X minus 3 equals plus or minus radical 5. And then to solve for x, just isolate x. So add 3. That would be like put a 3 out here, plus or minus radical 5. Divide the whole thing by 8. 3 plus or minus radical 5 all over 8. That's it. All right. This is not incredibly long. This quiz is just a quadratics quiz because we're going to move on to polynomials. So This is a quiz going in the test category. So it's worth half a test, basically. Tests are worth 100 points. This one's worth 50. And the reason this review says quiz is because I just took the quiz and made adjustments to the problems, but this is the layout of the quiz. All right? Come into office hours if you have any questions.